Alright, so we are going to jump right into this video. We are reviewing for the test tomorrow, which is the test 3.3. It should be a cumulative exam, so it's going to go over everything we've done in the third 6 weeks. So it's going to be a lot of factoring and a lot of quadratics. So in this first section, we're completing the square. And that's where we want to create a perfect square. So we'll have ax squared plus bx plus something. That's that process where we add something to create our perfect square binomials. So the first thing we want to do is get rid of whatever's on the same side. So now we have x squared plus 14x plus something is equal to 3 minus 16 is negative 13. Whatever we do on the left, we have to do on the right. So if we're adding something on the left, we're going to add that same number on the right. And then we are going to create our perfect square by taking the sign that we have there. So plus comes down, and then 14x, we're going to divide by 2, that coefficient. So we get 7, square it, and put it in the blank. So we have x plus 7 squared is equal to, and then negative 13 plus 49 36. So this says solve by completing the square. So in order to solve, now we're going to take the square root on both sides. And we get x plus 7 is equal to plus or minus 6. So we'll subtract 7 on both sides. And we'll get that x is equal to 6 plus 7. And x is equal to negative 6 plus 7. So x equals 13 and x equals 1. So when we complete the square to solve, it's kind of a mixture of completing the square at the beginning and then solving by square roots in the end. We'll do the same thing on number 3. So we are going to complete the square by moving that 17 over first. We get v squared plus 8v plus something equals 25 plus that same thing. V plus 4, because we take that 8 and cut it in half, square it, put it in the blank. 25 plus 16. Oh, I'm sorry, that's negative 8 plus 17. It's 9 plus 16, which is 25. There we go. And then we're going to take the square root on both sides. We get v plus 4 equals plus or minus 5. So v plus 4 equals 5, and v plus 4 equals negative 5. So v equals, we'll subtract 4. We get v equals 1. And we'll subtract 4, and we get v equals negative 9. Excuse me. Now we're going to do the same thing on the next ones, but we have a number in the front. So this is like the video completing the square when a is greater than 1. So the first thing we're going to do, like before, move that 18 over. We have 2n squared minus 16n is equal to 18. The reason I didn't put that blank there yet is because we have to take out the 2. So n squared minus 8n, because we're factoring out a 2, plus something is equal to 8 plus that 18, sorry, plus that same thing. So now what we're going to do is create our perfect square. So n squared minus 4, not n squared, n minus 4, then all squared. We get 16 here, so 2. So 16 goes, so 16 would go in this blank here, but remember we've got that 2 right here in the front. So 2 times 16 goes in this blank, which is 32. 18 plus 32 is 50. So then we have to divide everything by 2. We get n minus 4 all squared is equal to 25. And then we're going to take the square root on both sides. I get n minus 4 is equal to positive or negative 5. So n minus 4 equals 5, and n minus 4 equals negative 5. So n equals 9, and n equals negative 1. We'll do the same thing on number 7. So first thing we're going to do is move that 20 over. 4p squared minus 16p is equal to negative 20. Then we'll take out that 4. P squared minus 4p plus something is equal to negative 20 plus that same something. We can't forget that we have to multiply by 4 whenever we put that same thing on the right side. So we've got 4 times p minus 2 squared. We take that 4 in half, and then we square it, put it back here. 4 times 4 gives me 16 on the right side. So negative 20 plus 16 is negative 4. Divide by 4. P minus 2 squared is equal to negative 1. And then we're going to take the square root on both sides. This ends up being imaginary. So if you can get to that step, that should be fine, because we have not dived into complex numbers yet. So if you end up with a negative underneath your square root, then on the review, I know there's no negatives on the test, then just stop there and say that it is an imaginary answer, but you know the completing the square steps. Then on the next section, solve each equation by factoring. So before we were solving by completing the square, now we're solving by factoring. So there is no a right here, which means a is 1. So when a is 1, we're just looking for those two numbers that multiply to the last term but add to the middle term. So I need two numbers that multiply to 5 but add to 6. It's 5 and 1. So x plus 5, x plus 1, and then that's equals 0. We're solving, remember? So we're going to use that zero product property and I say x plus 5 equals 0 and x plus 1 equals 0. So x equals negative 5 and x equals negative 1. So on the next two, we have an a value that is greater than 1, so we are going to use the slide and divide method or the California method. It's the same thing. So the first thing we see that it equals 3, so first I need to get everything over so that it equals 0. So 3n squared plus 10n plus 8 is equal to 0. Once it equals 0, then I can start working with it. So with the slide and divide, I'm going to move this 3, I'm going to slide it over to where the 8 is, and multiply those two. So that leaves me with n squared plus 10n plus 24 is equal to 0, because we multiplied the 3 and the 8. And then we're going to factor this the same way we did the first one. So n and n. Two numbers that multiply to 24 but add to 10, 6 and 4. But we can't stop there because originally we multiplied by a 3, so I need to divide it now. So first I slide, then I divide. And n plus 6 over 3 is the same thing as n plus 2. N plus 4 over 3, we don't want to have a fraction in there, so I'm going to multiply the 3 in the front and get 3n plus 4 equals 0. If you're confused on how I just did this with using the slide and divide method, Ms. Hernandez has a video that I posted during the week we did factoring greater than 1, and then you can watch that video and she goes over different methods. So now we have n plus 2 and 3n plus 4 is equal to 0, so I'm going to set each of those equal to 0 to solve. And n equals negative 2 here. Here we'll show the steps. So we have 3n is equal to negative 4. And then we divide by 3. And n equals negative 4 over 3. So my two values for n are negative 2 and negative 4 over 3. Then on number 13, we'll do the same thing. So the first thing I want to do is make sure that it equals 0. I see that it equals negative 3, so I'm going to move that over. So 2b squared minus 5b is equal to, plus 3 is equal to 0. So now I'm going to use that slide and divide method, so I'm going to take 2, move it over to where the 3 is, rewrite the problem as b squared minus 5b plus 6. I multiply them, so 2 and 3 equals 0, and then we will factor this the easy way. So b and b, two numbers that multiply to a positive 6 but add to a negative 5, negative 3, negative 2. So then we have to divide by 2 because we originally multiplied by 2. So we got to undo what we did. We get b minus 3 halves, which is a fraction, so 2b minus 3. We move that 2 to the front. And the other factor is 2 over 2, which is 1, so b minus 1 is equal to 0. Using that zero product property, we have 2b minus 3 equals 0, and b minus 1 equals 0. So on this right side, b would equal positive 1. On the left side, we got 2b equals positive 3, divided by 2, and b equals 3 over 2. So my two values of b are 1 and 3 over 2. Now in the next section, we're solving by taking square roots. So what we're going to do is get everything away from the variable. So move it to the other side and then take the square root of it. So here we want to subtract 10. And we get v squared is equal to 0. Which when you take the square root of 0, you get 0. So v would equal 0. On the next one, we're going to do the same thing. We're going to move that 3 over. So we get x squared is equal to 90 minus 3, which is 87. And then we're going to take the square root on both sides. So x equals plus or minus square root of 87. Which I'm not sure if it can simplify. Let me see. Alright, so no, it cannot simplify. So we keep it as it is. X is equal to the positive and negative square root of 87. So I'm going to do the left side of the next page as well. So on number 19, that's hard to see, we're going to solve the same way. So we're going to divide by -3 first. I do apologize that it's so hard to see. I zoomed in quite a bit. And then we have x squared equal to 42 divided by -3, which is -14. We'll take the square root on both sides. We are going to get an imaginary number here. So x equals plus or minus I square root of 14. Square root of 14, I think, can simplify. No, they can't. So it's just plus or minus I square root of 14. Again, on the test, there are no imaginary numbers, so just be aware of that. On the next section, we're using the quadratic formula. So x equals -b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So on this first one, 21, x squared minus 121 equals 0. A is 1, b is 0 because there's nothing with just x, and c is -121. So remember that our standard form is ax squared plus bx plus c, and we want it to equal 0. So then we're going to plug those numbers into the quadratic formula. So x is equal to -b, which is 0, plus or minus the square root of b squared, 0, minus 4 times a times -121, which is c, all over 2a, so 2 times 1. So 4 times 121, oops, it's 484. So we've got -4 times -121, so we have a positive 484 underneath that radical over 2. Square root of 484. Square root of 44 is 22, so we have plus or minus 22 over 2. And 22 divided by 2 is 11, so plus or minus 11 was our answer. Which we could have done by moving this over and saying x squared equals 121, solved by square roots. We would have got the same answer. But it does say how to solve it, so we have to pay attention to if it's telling us a method to use, that we make sure we're using that method. Alright, so on the next one, this is really hard to read. We're going to move the 8k over, so we have equals 0, which is 3k squared minus 8k minus 128 equals 0. Let me zoom back in. So then what we're going to do is label our variables. So a is 3, b is -8, and c is -128. So x equals -b, which would give me a positive 8, plus or minus the square root, b squared, -8 squared, positive 64, minus 4 times a times c, and then all over 2 times a, which would be 2 times 3. Underneath that radical, we've got 64 minus 12 times 128. So 64 plus 1536. 8 plus or minus the square root of 1600 over 2 times 3, which is 6. So the square root of 1600 is 40, so 8 plus or minus 40 over 6. And then we can reduce everything by 2. So it's 4 plus or minus 20 over 3. You could leave it like this, that's fine. But since they're all numbers and there's no radicals in there, you would want to find what those numbers are. So 4 plus 20 is 24, divided by 3 is 8. 4 minus 20 is negative 16, divided by 3. So those are the values that you would find. And so either one would be fine, but on the test, remember it's multiple choice, so you're going to want to find the exact values. On the next one, we're sketching the graphs of the functions. So you want to find the vertex, you want to find the y-intercept. So on number 25, the vertex, we find by saying x equals negative b over 2a. And that's the x value, then we plug it back in. So a is 1, b is 4, c is 5. So x equals negative 4 over 2 times 1. So negative 4 over 2, which would be negative 2. So the x value of our vertex is negative 2, which means our axis of symmetry is cutting through there. And then we'll plug negative 2 back in, so y would equal negative 2 squared plus 4 times negative 2 plus 5. So that's positive 4 minus 8 plus 5, which is 9 minus 8, which is 1. So negative 2, 1 is my vertex, which is here, it looks like. My a value is a positive 1, so I'm facing up. And then the next thing I want to find is my y-intercept. So y-intercept is when x equals 0, so y-intercept is super easy with standard form, because those first two are going to cancel out. So my y-intercept is 0, 5, which is hard to see. I think this is wrong, actually. I think this is 1. So right here. And then 5 looks like it's here. So we're going to reflect across that axis of symmetry. Should be around here. And then so my quadratic function will look like that. On number 27, we're in vertex form. So my vertex comes from this and this. So my vertex is the opposite of what's on the inside, so positive 3, and the outside as it is. So positive 3, negative 1, right there. My a value would be here. So it's a positive 1, which means we're facing up. And then I'm going to try to find my y-intercept. So we would have 0 minus 3 squared minus 1, which would be negative 3 squared minus 1, positive 9 minus 1, which is 8. So my y-intercept is 0, 8, which is really hard to see on this graph. Let's see if I can... No, that didn't help. I can't tell what the scale is. I'm just going to draw a very rough sketch of that graph. You won't be asked to graph on the test, since it is multiple choice and since a lot of y'all are taking it online. So just be aware that you do have to find the vertex and you do have to find the y-intercept. So then the rest of the review is for you to do and submit, and then be sure to study before your test tomorrow. I'm so sorry about all the bells. Good luck.